All right, for this bell work, man, this is a nice mapping right here, and the left side of the map is always your x values. The right side is your y values here, okay? Now, as awesome as that is, we're just asking if this is a function or not, okay? So when we look at a mapping, we don't really care about the y values, okay? So pretty much all this stuff here on the right side, you just get rid of it, okay? Back, just to emphasize it. All we care about when determining if something is a function or not is looking at the x values on a mapping and seeing if there's more than one line, one arrow coming out of any of the x values. It could be more than one, it could just be one. If there's more than one arrow coming out of these, then we know it's not a function. But here I got one arrow coming out of 5 and 6, 7, 8, 9, and 10. Since there's only one arrow coming out of each, this one is a function. And it really is that easy with a mapping. You just have to look and see if there's two arrows coming out of any of these values. This one is a function. I can compare rate of change, which is slope, and then initial values, which is our y-intercepts. Do remember, though, that the rate of change, which is a slope, as long as they give us enough information, usually all we need is two ordered pairs, then we can find the slope, the rate of change, with the slope formula, okay? Now, sometimes they're going to give us the y-intercept, wherein we would know that the x is 0. We just find our y value from that y-intercept. But again, it would take two ordered pairs to figure out the slope there, okay? Remember, your x's are in the denominators, y's in the numerators. And rate of change is always like that. Y's in the numerators, x in the denominator. So even if they give us labels for the y's, we know that the label for the numerator is the y label. And then if they give us the x labels, then we know that that label will go into the denominator, okay? So that's how you can find slope. Of course, if it's a graph, you can use the stair-step method. Or if it's a table, you can just figure out the changes between ordered pairs. Now, on the other hand, they give us the y-intercept, which again is that's an initial value. As an ordered pair, the main thing we need to remember here is that the x value is always 0. Now, if they don't give us the y-intercept, the initial value, we can find it by taking one of the ordered pairs and just plugging it into this formula. Remember, it's y minus m times x, where the m here, that's the slope. And some of you still are, I think some of you are still confused on which one's x and y. That's from the ordered pair that they may give us, right? Remember, some kind of ordered pair, they would give us x value first, y value second. Okay, you just plug these values into this formula and then chug away, and you'll find out what your corresponding y value is in that y-intercept. So go ahead and take 15 seconds to copy that down. We got 3 different bathtubs, A, B, and C, and it's just asking which of these bathtubs is going to be empty first. Now, just so we understand what we have here, we've got 3 different bathtubs, but there are 3 different scenarios. The first bathtub, it just tells us in words, starts with 25 gallons and is drained 1.5 gallons per minute. That's nice. Bathtub B, however, is given, the values are given in a table, and then bathtub C right here is given in a graph. So let's figure out first, because it's very easy to tell how much water is in each bathtub in the beginning. Okay, because right here with bathtub A, it says right in the beginning it starts with 25 gallons. Starting with that 25 gallons, that means you'd have the ordered pair 25. It's starting with 25 gallons in the bathtub before they start draining the tub. Okay. Now, if you look at bathtub B, they said at 0 minutes, you had 25 gallons as well. That's a y-intercept right there, because the x value is 0. So we know that bathtub B, they're starting with 25 gallons. Okay. So right now we can see bathtub A has the same amount of water as bathtub B when they start to drain the bathtubs. Bathtub C is even easier to find because we're just looking for where this blue line goes through the y-axis. Boom, it's right there. Okay, now even though it's not showing a value, it's just 1 above 24. We see each line represents 1, 20, 21, 22, 23, 24. So this one would be 25, right? So we get 25. And they've already labeled this one right here in gallons for us. So that is actually the ordered pair 0.25. So again, this one also, they're just starting with 25 gallons, okay? Now, why is this important? It's because if they're all starting with the same amount of water, then all we have to do is to determine which one will drain fastest. That one will be empty first, whichever one has the highest drain rate, that one will empty first because they're all starting with the same amount of water. If they start with different amount of waters, then we'd have to take into consideration how much water was in the tub and then how fast they're draining, okay? So, how fast are they draining? Well, if we look at bathtub A here, boom, it's just draining at 1.5 gallon a minute. Okay, how do we know that that's the rate of change? Because it compared two things, gallons and minutes. In the same quantity, that's a rate of change, and so we know that we're looking here at slope. Okay. Now it's draining, so if you were to actually quantify this, you'd show it as negative 1.5. It's draining. Okay. All right, that's nice, but how about bathtub B? Because we need to find its slope as well. So I'm going to use the table, and we're going to say, look, let's use the two ordered pairs. Just use two ordered pairs that they give us. And I'm going to start with the y-intercept because we've already used it, 0.25. So remember, you're going to need to put the x values in the denominators, y's in the numerators. Same with whatever other ordered pair you use. I'm going to use x's in the denominators, y's in the numerators. Now for me, I just tend to use the next ordered pair. Even though they've given us a third ordered pair, I don't care. I'm just going to use the second one, okay? And in this one, it says the x value is 3 and the y value is 20, like this. So I'm just going to put this into my calculator. This will tell me the slope for bathtub B. So that's n over d, 25 minus 20, all over 0 minus 3. I get negative 5/3, but I want the decimal on this one. For me, it shows this as negative 1. It shows 6 repeating. I'm just going to keep it as 1. Well, I'll just show it with bar notation like this. Okay, and again, just since we're labeling this is gallons, because it is a word problem, gallons per minute. Now, just from these two bathtubs, bathtub A is draining at 1.5 gallons per minute. And again, the negative just tells us it's draining. Bathtub B is going at 1.6 repeating gallons per minute. Right now, bathtub B has a higher drain rate than bathtub A. So right now, bathtub B will be empty first between these two. But let's look at bathtub C before we make our conclusion, okay? So on this one, again, we have the ordered pair, 0.25. So I'm going to look to my slope formula, where I know that the x values, they go in the denominator, y's in the numerators, okay? And we started off with 0.25, just the same as the other two bathtubs. But then I need any other ordered pair that I know the exact values of. So I'm looking at this blue line. Does it go through any exact ordered pairs? It does. It goes through 2, actually. This one right here, and also looks like this one right at the very end. Okay, so what are their values? This one right here, that's at 321. And then this one right here, that's at 6, looks like 17 on that, okay? Now again, it's not showing the values, but I know it's right between, 21's right between 20 and 22. And then 17, that's right between 16 and 18, so it's 17, okay? Now, you don't have to use both, of course. You just need to use one. And I'm going to go ahead and use the 321. Okay, so I'm going to get rid of that 617 business. But I just need to remember, when I put this into the formula, x is in the denominators, y is in the numerators. So for this one, the x value is 3, and the y value is 21, right? So I just plug this into the calculator. This will tell me the drain rate of bathtub C. So n over d, 25 minus 21, all over 0 minus 3. I got negative 4/3. Again, I do want the decimal value on this one. It shows negative 1.3 repeating, okay? So as it turns out, we actually did not need, let's move this over. We did not need to show or round anything on this. Yeah, that's 1.3 gallons per minute. That's now fastest drain, okay? All right, so again, just going back to what we started with, we know each of the 3 bathtubs will start with the same amount of water. So all we have to do is figure out which one is draining the fastest right now, as far as I can tell. That is bathtub B, right? It's draining at 1.6 repeating gallons per minute. So I'm going to say bathtub. Which one's going to empty first? Bathtub B. Why will it empty first? Because it's draining at the fastest rate. Boom. All right. Now, who really sits there and watches water drain from a bathtub? I don't know, some kind of math nerd, I suppose. But there you go. On this one, 4 families are meeting up in Disneyland. Each family starts driving from home. Representations below show the distance each family is from Disneyland over time. And yeah, it tells us the variables there. X is time in hours, and Y is distance from Disneyland. So assume the families drive to Disneyland at a constant rate. There's something else that they should have included here, and that is that the families are, they're starting from wherever they live, okay, home, whatever it is, okay, because that'll be important when we look at the next few questions. So here's our questions. This relates to the first 2 questions, right? Which family lives the closest to Disneyland? Well, that's where we got to make that assumption that wherever they start, that's where they live in relationship to Disneyland, okay? Which family lives the farthest from Disneyland? Which one is traveling the fastest? Which one is traveling the slowest? And then who's going to get there first or last? Now, you may just think, well, whoever lives closest is going to get there fastest. Well, we just don't know, because you can live far away, but if you travel faster, you could get there faster. And yeah, for those of you that are familiar with Los Angeles or Anaheim or wherever the crap Disneyland is, yeah, we're neglecting traffic on this, okay? So ignore that there is or would be traffic. So we got 4 families here. We got family A, family B, family C, and family D. Let's look at each of these separately, and we'll just kind of put out any information that we can get on this, okay? So, and then we'll see if we can answer the questions as we go. Now, it's all a comparison, just like the objective says. So we're just trying to compare. Look, first we're going to do rate of change. That's speed, and then where they start from, that's the initial value, the y-intercept. That's going to answer the first 2 questions right there. All right. So let's look at family A. We got y equals 95 minus 55x. Now this is just a different form of y equals mx plus b. It's just they've just written it in a different format, that's all. Okay, so we could rearrange this. If you needed to rearrange this, then you could. You could say, well, you got y equals, you just take your x term first, which is negative 55. And then your constant 95 second. It's positive, so we show a plus right there, right? So right here, for family A, just from this information, we can see that family A, they live, because again, this is the initial value, the starting value, the y-intercept, that's 95 right there, so they live 95 miles away from Disneyland. Okay, so that's good enough for that equation to tell us how far away they live. But then they also say, look, here's your rate of change. The slope is negative 55. So this means they're traveling at 55 miles per hour. Now, what about the negative? The negative just tells us they're driving toward Disneyland. And Disneyland is too long of a word for me, so I'm just going to write Disney. Okay, so now we know for family A, we can see their speed and we can see how far away they live. That's part of the first 4 questions of this exercise, okay? Now, there's other stuff to it, of course, but we'll get there. Now, let's look at family B. So this one gave us pretty good information here. It even starts by telling us, look, they live 120 miles away from Disneyland, right? So that's nice. We already have that information. So I'm just going to kind of box this in. This is how far away they live from Disneyland, and it tells us how fast they were going. 60 miles per hour. So there's our speed, which again in this case is our slope. And then they also gave us the y-intercept, which is an initial value. Okay? So we know how far away they live from Disneyland, and we know what speed they travel at. Now, if we were just to compare these first two families, right now, family B is going faster than family A, but family B lives further away, right? They're 120 miles away, 95 miles away, okay? Now, you could think, well, this family's going a little bit faster. Are they going fast enough to get there before family A? We'll look at that. Okay? Now, how about family C? Well, they did start by giving us this ordered pair right here, and the x value is 0. So this is actually our y-intercept right there, which is good news because that tells us then, right now, that they live 80 miles away. So that's our y-intercept, and again, that's good enough that we can compare with the other two families. 80 miles away is closer than 120 or 95. And it was given to us in the table, so we didn't actually have to look for it. All right, pretty convenient. But now we need the slope. So, to find the slope, I will use the slope formula on this one. And we already have the y-intercept, right? Remember, your x is in the denominators, y in the numerators. And for the y-intercept, the x is always 0, but the y value on this one, its corresponding y value is 80. So that's the ordered pair 0, 80. Now I'm going to use this other ordered pair, 1.5 and 5, remembering that the x values go in the denominator, y's in the numerator. And in this case, the x value is 1.5. It's okay to have that decimal because the calculator is just going to do all this work for me anyways. And then its corresponding y value is 5. So I'm going to go to my calculator. I push the n over d button. I got 80 minus 5 all over 0 minus 1.5. I push enter, and the calculator says we get negative 50. Okay, now don't worry about the negative. Once again, the negative here, that just tells us they're going toward Disneyland, okay? They're getting closer to Disneyland. But this would then tell us that they're traveling at 50 miles per hour. Now again, we can compare that with the other three families that we figured this out for. Family B is still going faster than family C, and of course they were already going faster than A. But family C, they're going slower than family A, but they do live a little bit closer, right? Again, is that going to be enough to get them there first? We'll find out. But right now, we're just focused on how far away they live from Disneyland and then the speed that they are traveling at. Well, that's family C, A, B, and C. Let's look at family D now, all right? So this one is a graph, no problem. Remember your graph, it's gonna pretty much just show you where the y-intercept is. Boom, it's right there. Now that is right in between 40 and 50, which tells us that we're looking at 45 right there, which means the ordered pair itself is 0, 45. Okay, so again, what does this mean? This means that family D, they live 45 miles away. So that's our y-intercept, 45 miles away. But then we need to figure out the speed that they're traveling. So all I got to do is find any other ordered pair on this graph that this blue line goes through, okay? So I can use this point, this one. This one, again, this is pretty close. Don't be fooled by that one. It's not right on that, what is that, 0.430? So we got to keep scanning this line to see where it goes exactly through this intersection. And still, I mean, again, this one's close. It's getting a little further away, boom. Nails it right there. And so we're looking at this ordered pair right here, which is at, the x value is 1. Thank you. And then we can see that it's corresponding with this line right here. Now, it's not labeled for us, but again, you'd have to say, well, this has to be 0 because it's the x-axis. And then this one right here would be right between 10 and 0. That's 5. Okay, so I'm looking at the ordered pair 1, 5. And we can interpret this, right? 1, 5, we can see that X is represented by time. So that'd be hours, and then 5 here would be miles. So after 1 hour of travel, family D is 5 miles away. That's pretty close, but again, with traffic, maybe that's not so close. But let's compare these, all right? So let's come back. Yeah, that's good. So we have enough now to answer the first 4 questions. Which family lives closest to Disneyland? Well, from the first 3 families, family C was closest, but family D, they're even a lot closer. They're almost halfway between family C and Disneyland, right? They're, what, 2 times closer? So which family lives closest to Disneyland? I see family D does. D. You can put family D if you want, but it's more writing than I want to do. Which family lives the furthest from Disneyland? Well, just look at your y-intercepts, right? 45, 80, 120, and 95. Yeah, 120 is much bigger than those. That's family B right there. Which family is traveling at the fastest speed? Well, family B was already, and we forgot to find the speed for family D. Let's do that right now. All right, so family D. Let's go back to family D. We got the 2 ordered pairs. That's what I was starting right there. Put together our slope formula, and we already have our y-intercept, right? X is in the denominator, y is in the numerator. The x is always going to be 0 for your y-intercept, but the y value is 45. Then we got that green ordered pair. Remember, still x is in the denominator, y is in the numerator, but the x value is 1 and the y value is 5. So I can just put this into the calculator, and when I do, I'm going to get a negative. Again, that negative just tells us that they're traveling towards Disneyland. They're getting closer to Disneyland, okay? And I get 40 out of this. So this family D, they're going at 40 miles per hour. Okay, so now that I have that speed, now I can go back and I should be able to answer the rest of this question, right? At least C and D. So which family is traveling the fastest? So we had this family at 55, then 60, they're pretty close, but then 50 is lower, and then 40 is lower. So family B is also traveling at the fastest speed. So again, you gotta be careful with these, because just because they live furthest away doesn't mean they're gonna get there the slowest. The family B, while they live the furthest away, they're also traveling at the fastest speed. But which family is traveling at the slowest speed? Well, family A was at 55 miles per hour. Family B is 60, we know that's the highest, and then family C is 50. Boom, family D again, they're slowest. So they live the closest, but they're also going the slowest. Fair enough. Which family is going to get there first? Let's look at each family separately and figure out how long it's going to take them to get to Disneyland. Okay, let's start with family A here. So we got the equation. I'm going to go back to the original equation, by the way. Y equals 95 minus 55x. Yeah, but why the crap am I using that equation? Because that's what they gave us, all right? So what tells us that they would be at Disneyland? That's the y value. That's the distance from Disneyland. So if they were at Disneyland, and this is not, I'm not being sarcastic at all, but how far away are they from Disneyland when they're at Disneyland? That's 0. It'd be 0 miles away. Okay, so distance is y. So I replace that with 0. All I got to do is solve this equation. That's it. Okay, and this will tell me how long it's going to take family A to get to Disneyland. So my principles of equality here, subtract 95, negative 95, and then equals, that zeroes out. And we're dropping this as a negative 55x. Then I'll divide both sides by negative 55. And can't do that in my head, so the calculator. Okay, negative 95 over negative 55, enter. Give me a fraction, but I'm going to change it to a decimal. It's about 1.7. Now that's an x, right? Y is distance, x is representing time, so that'd be 1.7 hours. Family A will take 1.7 hours. Now that may seem like a long time, but let's see. How about family B? Now this one, they're going at a speed that's kind of a factor of how far away they live, or how far away they live is a multiple of how fast they're driving. So here's what I would do for family B, okay? I would say, let's look at family B. They're going at 120, they're 120 miles away to start with, right? So you could even show 0, 120. But then they're going to take off 60 miles after 1 hour. So after 1 hour, they are now 60 miles away. And then I can take off another hour, which would be another 60 miles. So after 2 hours, they are 0 miles away. See that? So family B, it will take them 2 hours to get to Disneyland. Now, could you have just made the equation for family B? Yeah, you could have, because they gave us the y-intercept and the slope. But I don't think a lot of people really appreciate the equation right there. Some people find it more torture than fun. All right, fair enough. Well, how about family C? And right now, just between family A and B, right? Family B is going to take a lot longer than family A. Well, we have the information for the equation for family C. So, you know what? That's what I'm going to do. Okay, so we have the equation. I'll use the equation again. Now, would you need the equation? Not necessarily. But I'm going to use it because it's convenient. So this is my equation. Y equals, the slope here was 50, but it's negative 50 because you're getting closer to Disneyland, X. Then we see the y-intercept, they're 80 miles away to start out with, okay? But again, the X's represent hours, and it's even shown in the table, right? The table says, hey, the X is this column and the Y is this column. So we know which is which. And if we go back to the last section, we then know which one is independent and which one's dependent, okay? Independence hours, distance is dependent. Which should make sense because how long they drive is going to determine how far away they are from Disneyland. So same thing as we did with family A. We want the distance here to be 0. So that's what I'm going to do. There's a 0 distance. All I got to do is solve this equation. So subtract 80 from both sides. So I got negative 80 equals negative 50x. And then just divide both sides by negative 50. So x then, let's see, we get, I got 1.6. So family C here, they're going to take 1.6 hours to get to Disneyland, okay? So even right now, family B is still going to take them the longest. They're at 2 hours. Family A, 1.7. Family C right now, between these three, is going to get there the soonest. And then for family D, you could write the equation for this, all right? But there's no need for it because, remember, we're just looking for where the distance is 0, and we already see the distance being 0 right here. So that's right on the x-axis, boom, right there. Now you could say that's, you know, like 1 point, I don't know, even like 1.5. That's not really going to matter because however you estimate that, it's still less than 1.2 hours right there. So just from this being less than 1.2 hours, family D is going to get there the fastest, okay? They're going to get there first, I should say. So family D, boom, you get there first. Again, they're going slow, but they live so close that it makes up the difference. And then who's going to get there last? Yeah, family B, it's going to take them 2 hours. Okay, so that's part of our objective. Not only do we need to be able to compare our rates of change, which is slope, and then the y-intercepts, the initial values, but you have to be able to do it in multiple different situations. Notice family A, that's an equation, that's on purpose. Family B is a word problem, that's on purpose. Family C is a table, that's on purpose. And family D is a graph, still on purpose. Okay, you have to be able to compare between these types of representations. So you can rent a boat from one of two places. Looks like we got the goat boat rental, and then also boats for rent. The prices are represented below, where X is the number of days and Y is the cost. So, yeah, on this one, let's look at the goat boat rental first. Okay, so we know X is it's the number of days you're going to rent the boat for, and then Y is the cost. Now, this one, they gave us the rate of change right here. Remember, this is the coefficient of X. That's 10. I'm going to show it as 10 over 1 because it is a rate, so we should have two labels with the rate. And remember, just like we've seen before, it's always X values in the denominators, Y is in the numerator. So in the beginning, when they say, hey, Y is the cost, then we know that the 10 is $10. Then it said the X is the number of days you're renting this boat for, so that would be the label for your denominator. Okay, so $10 per day. Again, this is our slope. This is the rate of change. And then also they say, hey, look, you got a plus 60 right there. That's a y-intercept value. Which as an ordered pair would be 0.60. But what is this telling us then? Well, the y, remember the y value is 60, and the y values are cost. That's dollars. And at see the x value here is 0, so that'd be like $60 for 0 days. That means in this particular scenario, it's some kind of $60 fee, like a rental fee. Maybe it's like a membership fee, something like that, okay? But you got to pay the $60 up front, and then you can take the boat away. And if you're like, you know what, I don't want to take the boat, they keep you $60, okay? I guess in this math situation. I don't know if they would in real life. Okay, but that is the scenario that we're looking at with the GOAT boat rental. Let's look then at boats for rent. Okay, so what do we see about boats for rent? I see that this line is going exactly through the origin. That's at 0, 0. So this 0, 0, the y value being 0 tells us there's no starting fee, no initial fee for boats for rent. They say, hey, look, you're going to rent from us. We'll just charge you some kind of rate per day. Now, since this is going through the origin, and I don't think many people remember this, if it goes through the origin and it's a straight line, this is what we call a proportional relationship. I don't think you care, but the reason why this is important is because now when I look to find my slope, all I got to do is find the value of y where x is 1, okay? So I see that this is, that's 30 for my y. That's $30 for 1 day. Okay, so right here we have the no fee to start with, but it's $30 per day. Let's go back and let's compare that with the GOAT boat rental. So the GOAT boat rental, boom, $60 just for some kind of initial fee, but they're charging a lot less per day, right? $20 less per day. So if we think about this, we should know that if we're going to rent for fewer days, then it's likely that boats for rent should be cheaper, right? But if you start renting for longer periods of time, because of the low rate at GOAT boat rental, it's going to end up being cheaper. Now, that's not going to matter right now. Let's look at the first question. Which rental costs less for 3 days? Now, the nice thing about the graph is it even shows right here, hey, look, there's 3 days right there. I just followed the line up, and I see that that would have costed $90. So that's our ordered pair there, $3.90, which tells us boats for rent. Here, that ordered pair tells us it's going to be $90 for 3 days of rental. Okay. Now again, why is this important? Because we're looking for 3 days, how much it's going to cost for 3 days. Right now we know how much it will cost from boats for rent for 3 days, but we just need to use the graph for that. Could you have written an equation for boats for rent? Sure you could have, right? Y equals mx plus b. And we already found the slope, that was $30 per day, but the y-intercept, boom, plus 0. So you could have used the equation if you wanted to, okay? But the nice thing about this, the graph gave that to us. All right, well, that's nice, but how about the GOAT boat rental? Well, for this one, let's look at the work here. Okay, so I'm gonna go back to the original equation. Y equals 10x plus 60. Okay, so right here on the left, that's the GOAT boat rental. Now we're looking for 3 days. X is number of days, so I'm going to replace that X with how many days it is, 3. And this will tell me the cost. And when I put this into my calculator, it tells me that the GOAT boat rental, that's the Y value, that's the cost. And I just put this in my calculator, 10 times 3 plus 60, boom, I get $90. Again, that's $90 for 3 days of rental. Well, that's interesting because $90 for 3 days, that's the same price it was for boats from boats for rent. So it turns out that which one will cost less? Neither. I guess you could say both. And did I spell neither right? I don't know, but I also don't care. So there you go, neither. They're just both the same amount. Which means if you know you're going to rent for 3 days, if you know for sure you're going to rent for 3 days, that it doesn't matter which company you go with. Maybe one's closer, maybe one's more friendly. Whatever is important to you, you can go with that company, okay? All right, fair enough. So that's 3 days. Now, before we continue, let me clean up this graph, right? So I'll get rid of this stuff. even though we used it. Okay. So here's what this is telling us. Let's look at the goat boat rental. I'm going to do this one. I'm going to make it orange. But what I'm going to do is I'm going to put it on the graph. Okay. What this is going to do is it's going to show us a line for the goat boat rental. And what I see there is that its initial value is $60. Well, I can put that directly on the graph right there, $60. And then I know also that it's $90 for 3 days. That's this point. Now you see that it's the same point that was on this line right here. It was 3 for 90 for boats for rent. So it is, it's the same point. They should come together, the two lines. But now that I have that, I'm going to take that line, these 2 points, and just make a line. There we go. Okay. Why is this important? It's because if you're looking at the two companies, we can tell visually which one will be cheaper for really what is beyond 3 days. So there's kind of like a marker right here. Let's see if I can do this better. You know, well, that's okay. Nice steady hand, right? Well, whatever the case is, that is at 3 days. Okay, at 3 days, that's when two companies are exactly the same. But you see, if you go to the left of 3 days, see how this line, that's the goat boat rental, this orange line? That's above the other line that was for boats for rent. And yeah, I don't know who actually advertises costs on a graph. Freaking jerks. But in any case, that's what we got. But since this line is above, the goat boat rental is above the boats for rent, that means it's more. But you see, as soon as we hit 3 days, then it's below the boats for rent. So anything less than 3 days, the cheaper option is boats for rent. If you're renting for more than 3 days, the cheaper option is the goat boat rental. So this one, see how it's 30 days? Now it's a lot more than 3 days right there. Of course, then that would be the goat boats. These ones are going to be cheaper. They're going to cost less for 30 days because it's beyond the 3 days. Well, which one will be, which one's going to cost less for 1 day? Well, that's, again, 1 day is right here. We can see that 1 day is $30 from boats for rent, but it'd be way up here beyond 60 for the goat boat. So the second one for 1 day, that's boats for rent. All right, that completes that problem right there. See this kind of stuff on the assignment too. It's going to give you, and these are all going to be graphs, which is convenient if you ask me. But it's just going to ask increasing or decreasing functions. When it's asking for increasing or decreasing, it's just looking at the slope. And increasing would be a positive slope, decreasing is a negative slope. Which is why increasing goes up from left to right, decreasing goes down from left to right, okay? So if you looked at lines on a graph, an increasing line would be something like this. And we're going to pretend that my lines are straight, although they don't necessarily have to be, okay? This one is going up from left to right, and it could be steep as well. You know, you could have something like this one, where it's pretty steep, like this. It doesn't have to be steep, just be shallow, but as long as it's going up from left to right, it is considered increasing. If it is decreasing, then it has to go downwards. So this would be a downward slope, okay? And again, we always look from left to right, so it's like saying, hey, you're gonna take a sled up here, you're gonna go down the hill. On this one, you'd have to start here on the left, you'd go up the hill, something like that. Can it do both? Sure it can. We've seen something like that, where maybe it even starts to go up, then suddenly it shifts direction and goes down, something like this. This one would be both, because it goes up and then it shifts downward. But you could have some kind of oddballs like this, where it's even non-linear, something like this one. That one does both. Or I'll do one more. Okay, this one starts going upwards and then it shifts back downwards. Kind of like what we saw before, but it's just curvy, that's all. Okay? Now this one again, it's kind of a funky one, but this one would always have a upwards direction, but it'd be something like this. Okay, it may not look like it, but that one's still a increasing function because it's going up from left to right. How about positive or negative? Well, positive, this is all in relation to the x-axis. When it asks for positive or negative function, you're just always looking at the x-axis, always. Okay, so there's our x-axis there, and there for these three, right? If it's a positive function, it has to remain above the x-axis. So what you may see is something, it may be even straight, right? So you could say, look, see this one right here, and then they're going to put points like this on the ends. It's going to look like a line like this one, okay? Now, the fact that these are circles, they're kind of important. Only that it goes down, it stops right here before it gets to the x-axis. This one's considered positive, okay? Now, that may seem kind of complicated, but I think you're going to see it. On the other hand, you just may see some that are, yeah, it's kind of like, it's curvy. Maybe it's even kind of funky like this. But see how it never actually crosses over the x-axis? It's always above the x-axis. Therefore, it is considered a positive function. Negative function is just the opposite. It's got to be below the x-axis. So again, you may have something like this. Again, that never actually crosses over the x-axis, always below. Or again, you may have something like dots like this, and then it's just like a line. Sometimes what they'll do is they'll make the line kind of funky as well. That connects these two, something like this. Yeah, whatever. It's still below the x-axis, so it is considered negative, a negative function. Sometimes it's above and below. Okay, no problem. You know, something like this one, right? It could have points at the end. It could have arrows. Doesn't really matter. The moment that you see that it crosses over that x-axis, it's both. Maximums and minimums then. So when we're looking at the highest point on these, the highest point and the lowest point, highest point, lowest point, right? All these are related to the y values. Oh, spell values right. There we go. The y values. I don't care about the x values. We're just looking at the highest and lowest point. That's up and down. Okay. So if we look here at the maximums. Okay. So if you have a line like this, maybe, and sometimes again you're going to see points like this one, and then maybe the line just kind of comes down here. And sometimes you'll see they're open circles. That doesn't really matter. But this point right here is considered the maximum. And again, it's related to its corresponding y value right there, whatever that is. Okay. Now, if by chance we saw that the maximum here, so let me make another graph here. I'll do this one on the right. So we'll pretend like my lines are straight, and this is my x and y axis. So sometimes it can be infinity. Here's how that will work. Okay, so, and sometimes it's even kind of curvy like this one, right? But if it goes to infinity, you're going to see an arrow right there. That's the main thing that's going to tell you that that this line, the maximum, it just goes up forever, which means that it's infinity. Now, how do you type in infinity to Canvas? It's just a double O. That's the letter O. Put two O's there, and then it will know that you mean infinity. Okay. All right, so that's maximums. Well, what about minimums? Well, minimums is the bottom of the graph. Okay, so like on this one that we've already put there, this point right here would be considered the minimum. And again, it's related to the y value. I don't care what the x value is. It's up and down. Highest point, lowest point. This is the lowest point on this graph, right? So is it possible that you can have negative infinity? Sure it is. So if you see something, even something like this one right here, if you see it's the arrows that you're looking for, see these arrows right here? This tells us that it goes all the way down to negative infinity. How do you put negative infinity into Canvas? Put a negative sign and then two O's. That's the letter O, not the number. Now, if you saw something like this as well, even though it may not be so clear, but like the highest point here, the very tip of that is a parabola. That would be considered the maximum right there. And that can be a number, but you see on this one, since we got the arrows, you got negative infinity. Now, the last special case you're going to see is something that it's curvy, but it kind of flattens out the line wheel. So you may see a line that looks, I don't know, something like this. I think I can do better than that. Let's try that again. Okay, then you'll see even that it's got an arrow pointing to the side right here. This one goes up. So if this one asks for a maximum and minimum, the maximum I can see, this one, it's gonna go all the way to positive infinity, okay? So again, that's a double O on the computer. But you see how it got really close to the x-axis, but it's not quite there. That means that it's kind of flattening out where x is 0. So if it asks for a minimum here, the minimum would be 0, okay? Because it's just flattening out. That's it. There's our objective. I can compare rate of change, which is slope, and initial values, which is the y-intercepts in functions.